Welcome back, students. So in this lecture we are going to discuss about plane mirror, basically characteristics of the image formed in plane mirror, and after that we will do some problems, some questions, and then we are going to discuss about spherical mirrors. So basically the first part of this chapter, that is reflection, is about to start. Reflection by spherical mirrors. So let's start. Now as you can see that first of all we are going to discuss about the characteristics of image formed by the plane mirrors, right? The type of images plane mirrors form. We know that these type of images are usually virtual, right? The plane mirrors form a virtual image, and these images are basically of the same size as of the object, right? And also they are erect and of equal size as of the object, right? And the distance at which this image is formed behind the mirror is exactly equal to the distance of the object from the mirror. So you can say that if this is mirror, and here for example at a distance of 1 meter we have an object from the mirror, so its image will form behind the mirror exactly 1 meter behind the mirror, right? So the total distance between the object and the image will be 2 meters. 1 meter, the object will be 1 meter away, for example, from the mirror. So from the mirror 1 meter behind it will the image be formed. Okay, so and one more important thing, that is that this object is the image formed by the plane mirror is actually literally inverted. That means the inversion is taking place, and you see that if I raise my left hand in front of the mirror, in the image it will look like that I have raised my right hand. I hope this is clear, right? Now let's talk about some questions now. So the first question is, an object is at a distance of 0.5 meter in front of the plane mirror, and the distance between the object and the image is. It is basically asking us the distance between the object and the image. Suppose this is my mirror and this is my object, suppose, and this object is at a distance of 0.5 meters. We know that the image formed by the plane mirror is exactly at the distance behind the mirror, right, as the object was from the mirror. So that means exactly 0.5 meters behind the mirror we will have our image, right? So the total distance between image and object is 1 meter, right? So option B will be the correct option, right? Now let's see the second question. Find the angle of incidence and angle of reflection from the diagram. So this is our diagram and these are our options. So as we can see that the this is our normals. Let's suppose I name is at NO. This NO is our normal, and this, for example, AO is our incident ray. That means AON, angle AON will be our angle of incidence, right? So it is asking us to find the angle of incidence and angle of reflection. We know from the second law of reflection that angle of incidence is equal to angle of reflection, right? So if we can find our angle of incidence, we know our angle of reflection also. Now the question has given us this angle made by the incident ray with respect to the surface, right? But we know that the angles are measured from the normal. So if this is the normal, therefore this angle would be 90 degree from the surface, right? So if total angle is 90 and the angle made by the incident ray with respect to the surface, that is this angle, is 35 degrees, so 90 minus 35 would be how much? 55 degrees. So therefore our angle of incidence is 55 degrees, and same amount of angle or similar value would be for our reflected angles. That means angle of incidence is 55 degrees and angle of reflection is also 55 degrees. I hope this is clear. Let's move on to our next topic. So our next topic would be about spherical mirrors. right? So basically, what are spherical mirrors? The mirrors which are basically spherical in shape are simply called as spherical mirrors. Now imagine we have a sphere, for example, a big sphere made up of glass, a hollow sphere, by the way, right? Sphere like a ball but hollow. Now imagine this hollow glass sphere, we cut a part of it, for example. Now as it is a sphere, definitely it would have a center, right? It would have a center. So suppose this is its center, this is its center. Let's denote this center with C, okay? And the distance between the circumference and the center, let's call this distance as a radius of sphere, right? Now what I'm doing is I'm cutting a part of the sphere, for example. This is the part I'm cutting. I'm taking it out, for example. Let's suppose I'm drawing this here. So I'm drawing this kind of part of the sphere on the side of this slide, for example. Now what I'm going to do is, for example, if I paint this sphere or polish or kind of coat with silver paint on its back side, for example. Let's suppose I'm coating the silver because silver is the best reflector, right? So if I coat this glass from the outer side, right, that means the inner side now becomes reflective. This inner side now becomes reflective, right? What basically is done is that over this coating of silver, another coating is done basically of red paint, so to basically save this coating of silver so that it doesn't kind of scratch away, right? So the inside of this curvature becomes reflective now. Now obviously the properties or the characteristics of the sphere are same, right? Because this part of this sphere is exactly having the same center. So suppose this was its center, right, denoted by C, and the distance from the center to the curvature or this circumference, part of circumference, let's call this as radius. But now we name it, we have a special name for it. We call it as a radius of curvature. A radius of curvature. Earlier we used to call it as radius of sphere. Now we call it as radius of curvature. And the C is nothing but center of curvature, right? And what else? The length of this mirror which we have cut from the sphere, for example, I am naming it as mm dash. This mm dash is nothing but aperture of sphere. Aperture of sphere. So the maximum or the biggest aperture can be the diameter. Like if you cut at the center of the sphere, it will definitely be the diameter, right? So as big as aperture you have of this mirror, the bigger the mirror will be, okay? And the biggest aperture you can cut is basically the diameter. Is it clear? Okay. Now some other things which we have to look after. So these are the few simple things here. Now let's see what else we have here, right? So the type of mirror I had, let's see. So I had a kind of mirror which I painted from outside. So this is what I did. I painted with silver from outside, for example, from this side, right? And then I coated it with the red paint so that it is saved from the scratches and my silver coating doesn't go away, otherwise it will not work as a mirror anymore. So you see this type of mirror where the reflection actually the reflective side is from inside, this type of mirror is known as concave mirror. Concave mirror, like you have silver coating on this side and on the silver coating you paint it as red, so therefore this side is this cave side is the reflective, therefore this is your concave mirror. But if you do reverse of it, that means if you basically coat it from inside, if you silver paint it from inside and then red paint from inside, therefore this will be your reflective side now. So this is your convex mirror. So if I do the same thing, suppose, so this is my mirror, for example, this is my mirror, this is my mirror, and what you did was you paint it from inside. For example, this is what you are doing, you are coating with silver from inside and then you are red painting it from inside. So that means this is its reflective side, this is its reflective side, reflective side. So this type of mirror is known as convex mirror, convex mirror, right? Now take a look at the center of curvature where I am putting that. So if I am talking about concave mirror, definitely this is where its center of curvature will be, right? And if I am talking about this convex mirror, so on this side of the mirror will be my, so this side is reflective and this behind the mirror will be my center of curvature. And if this is my mirror, concave mirror, so as the reflective side is on the front side, so I would say that the center of curvature is facing basically on the reflective side, right? And if I am talking about convex mirror, I would say the reflective side, the center of curvature is behind the reflective side, right? In case of concave, let me repeat it once again, in case of concave mirror, the center of curvature is in front of reflective side, and in case of convex mirror, the center of curvature is behind the mirror or behind the reflective side. Is this clear? Let's see. So there are two types of mirrors, one is concave, one is convex, and in concave mirror what you see is that the center of sphere is basically, see here I am talking about center of curvature for concave mirror is basically in front of the mirror here, this is your reflective part in front of the mirror, and in convex mirror this is your reflective side and the center of curvature is behind the mirror, right? Now some important terms for the spherical mirrors we will discuss in next lecture.